Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. Now take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Minimum and Maximum Dominoes by MD88 Keys, or as I like to call him, Dr. Piano. We have normal Sudoku rules apply, which means in each cell, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which are boxes. We have digits in a cage sum to the given number. So therefore, these two digits add up to 5, these two digits add up to 17, these two digits add up to 14, etc., etc. So if this were, say, a 3, this would have to be a 2, because those two digits must add up to 5. That's an example of how killer cages work. And cages indicate the minimum and maximum sums of orthogonally connected pairs of cells within a box. So orthogonally connected cells are basically just cells which share an edge. So these indicate the minimum and maximum values that you can have in a 3x3 box between two cells that share an edge, right? So you know there are no other, so to continue, we have a negative constraint. All minimum and maximum cages within a box are given. There cannot be a domino that sums to a number less than the minimum cage, nor can there be a domino which sums to a number greater than the maximum cage. Oh, there also cannot be a domino equal to the minimum or maximum unless it also is marked with a cage. Okay, so basically, I don't know why he separated those out. You could just basically say there cannot be a domino that sum to a number equal to or less than the minimum cage, and nor can there be a domino which sums to a number equal to or greater than the maximum cage, right? Right, because like for example in cage 1, we have 2 cages which add up to 15 here. Right? That shows that basically if you have a number equal to the maximum, you will be designated with a cage between a domino here. That means every other scenario, the dominoes must be between the maximum amount in that 3x3 box and the minimum amount in that 3x3 box. So every other domino setting must be, again, less than the 15 here and greater than the 4. It cannot be equal to 4 because every time you would have a 4, it would add up. And every time you have a 15 or more, it would add up. And it would show as a cage. So these dominoes show us the minimum and maximum values, sums for any 2 dominoes in that cage, in that 3x3 box. Apologies, I think I might have said cage, but it's actually in the box. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so these are maximum and minimums. We should have 17s and 16s and 3s and 4s available. So these all have to be 8 and 9 for the 17s. For the 16s, this is 7 and 9. We have how many 3s? Just 2. 1 and 2. For 2 digits adding up to 4, it's 1 and 3. So those are the ones that we have exactly one pair for, and we know exactly that they are. Okay, so these 8-9 pair eliminates 8 and 9 in the rest of the row, so this cannot be 8 or 9 here. This is 8 or 9 with 5 or 6. This must be 8 or 9 with 6 or 7. And this is also 6, 7, 8, 9, because any two digits adding up to 15 is 6 and 9 or 7 and 8. And in this box, since we have both 15s here, the rest of the box must be 2, 4, and 5. Okay, what we cannot have here is 9. If this is 9, this becomes 6, and this would have to be 7 and 8. And these two would add up to 16. So this cannot be 9, this cannot be 6. Therefore, 6 has to be one of these two digits here. What else do we have? In column 6, we cannot have digits from 1, 2, or 8, and 9 because of the 1, 2, and 8, 9 pairs in the column. So it must be 3 through 7 for the rest of the digits. This can't be 7, this can't be 3 because of the 1, 3 pair and the 7, 9 pair in the rows. Same with that, that can't be 7. What else can we have? This is maximum. So 7. Where is the 7 in box 5? Excuse me. Cannot be here, cannot be here, cannot be in the 17 cage. It must be here. So this is 7. Also, this 1, 3 pair eliminates 1 and 3 in the rest of the column. This can't be 1 or 3, so this is 2, this is 1. What else do we have? The rest of box 5 has to be 3, 4, 5, 6. And this can't be 3. Any of the 5s must be the digits 1 through 4. Because it's either 1, 4, or 2, 3 adding up to 5. All of the 14 digits must be 5, 6, 8, and 9. Okay. What does that tell us? I'm not really sure, but... So 7 has to be one of those. The remaining digits in row 5 have to be 1 through 6. 8 and 9. Okay, so 8 and 9 cannot be in column 9. So that means where is the 8 in box 6? It must be one of these two. So that means where is the 8 in row 4? Cannot be here because of the 7, 9 pair having to be here, and this 8, 9 pair eliminating 8 from here. Can't be here because of the 8, 9 pair in the box. Can't be here because of the cage. That adds up to 5, so this must be 8. Which eliminates 8 from being here. So this can't be 8, which means this can't be 6. Where can the 7 be in column 9? Cannot be here because of the 7, 9 pair. So it has to be one of these 3 digits here. Is a 7. Okay. Do we have anything else? The rest of column 4 has to be 4, 5, 6, 8, and 9. Okay. Well, we know because one of these digits is 8 and 9, and this digit is 8 and 9, the rest of column 5 cannot contain 8 or 9. Where are the 8, 9 possibles in box 2? Can't be here because of the 8, 9 pair. This is an 8, 9, but this can't be 8, 9 because of the 8, 9 pair. This can't be 8, 9 because of the 8, 9 pair in the column. Therefore, it must be here that it's 8 and 9. which means the rest of the row cannot contain 8 and 9 because of the 8 and 9 pair. This then must be 2, 4, 5, 6, and 7. This is 2, 4, 5, 6, 7, 2, 4, 5, 6, 7, 2, 4, 5, 6, 7, but these can't be 7 because the 7 in the box must be here, right? What else do we have? Okay. Where is the 3 in box 8? Cannot be here because of the 1, 3 pair in the column. Can't be here because this just adds up to 3. Can't be here because this adds up to 14. So 3 must be here, which eliminates 2, 3 as a pair here. That eliminates 1 and 4 as a pair in row 7. So this can't be 4. This can't be 4. None of these could be 4, which means in box 8, the 4 has to be here, which eliminates 4 in the rest of the row, or sorry, the rest of the column. So this is 5 or 6 here. Okay. That leaves in box 9, the rest of the digits are 2, 3, 5, 6, 7. Okay, then this can't be 3. Hmm. This digit has to be 1 through 6. But 6 can't be here. And 6 can't be here. So this is 1 through 5. Can't be 1 or 2. This is actually 3, 4, 5 here. Because it cannot be 7, 8, or 9. And 6 has to be one of these two digits here. So this can't be 6. Therefore, 6 has to be one of these two digits here, which eliminates 6 from being here. The rest of the digits in row 6 are 3, 4, 5, 6, and 8. Okay. 8 and 9, 8 and 9 are here. What digits can be here? You cannot have a digit from 6, 7, 8, or 9 here. If this was 6, that would add up with, this would force this to be 5 and 9, so this would add up to 15, which would be greater than the 14 here. And then the same thing with 7. 7 with 8 is at minimum 15. So this has to be 2, 4, 5 here. This could be 2, because 2 and 3 are 5, which is greater than 4, which is the minimum here. And of course it could be 4 or 5, so that's possible. Remaining digits here in row 1 cannot be 8 or 9 because this is one of these digits is 8 or 9 and this digit is 8 or 9. That eliminates all 8 and 9s in the row. And it cannot be 1, 3 because these are 1 and 3. And this is 1 and 3, which eliminates 1 and 3 in the rest of the row. So it has to be 2, 4, 5, 6, and 7, right? This cannot be 1 and 3. Where is the other 1 and 3 in row 2? It has to be here. So this can't be 7. This has to specifically be a 1, 3 because 1, 3 can't be here because of the 1, 3 pair in the box. 1, 3 can't be here because of the 1, 3 in the box. And this has to be 8 and 9. So this must be 1 or 3 here. Okay. This cannot be 1. If this were 1, it would be next to, at best, a 2 or 3. Sorry, at the greatest, a 2 or 3. And 1 plus 3, at most, would be 4, which would be less than the 5. So this cannot be 1 here. It could be 2 here, as long as this is 4. So this could be 2. Similarly, 1 cannot be either of these two cells, because if 1 is one of those two cells, the problem is that it would be next to a 2 or 3 guaranteed here. So 1 can only be here or one of these cells. Obviously, then 4 can't be here. 4 were here, this can't be 1, 4, but then there's no place for the 1 in the box. So that can't be 4. Hmm. Yeah. What is this digit? Cannot be 1 or 4. Can't be 6. It's pretty... It could be a lot of things. You cannot have a 9 here for the same reasoning. Right, if you had a 9 here, they would necessarily be next to a digit that's from 6 or 8. And 6 and 9 already adds up to 15. So 9 cannot be here, 9 can't be here. So 9 is either here, can't be here because of the same reasoning, right? If there's a 9 here, it's next to a 6 or 8, and that would add up to 15 at least. So 9 is either one of these two or it's here. So this can't be a 5 here. Therefore, we know in row 7, the 9 has to be one of those 3 digits. 9 similarly cannot be any of these. This cannot be 7. If this were 7, it would be next to an 8 or 9 guaranteed, and that's already greater than 14, right? 7 and 8 adds up to 15, so that's always greater than 14. So this cannot be 7. Actually, this can't be a 6 either, because it adds up to 6 and 8 already add up to a minimum of 14, which would force this to be a cage. So this can't be 6. This is 2, 4, or 5 here. This could still be 2, 4, 5, 6, or 7. We don't. Actually, in fact, yeah. Yeah, we don't have any extra information there. Because 7 could be next to 5 or 6, and it would still be less than 14. 2 could be next to a 3, and that would be greater than 5. Sorry, that'd be greater than 4. 4 is one of those two. This cannot be 8 or 9 because of the 8, 9. One of these has to be 8 and 9. That 8, 9. That cell has to be 8 or 9. So it can't be 1, 2, or 4. It can be 3, 5, 6, and 7 are the possibilities. Okay. So we have restrictions about where the 1 could be. So this digit could be 1. It cannot be 4 because if that's 4, this becomes 2, 3, and there's no other place for 1 in the box. So it could be 1, 2, 3, 5, and 6 are the possibilities. 8 has to be one of these two. Where is 1 in box 7? Where is 9 in box 7? So 9 in box 7 is either here or one of these two. Right. Um. hmm. Let's see. Do we have any other information? Yeah. For the fives and the 14 cages, we only can eliminate ones and nines. Two can actually be next to either of the five cages or the four cages because it could be next to the four instead of being next to the one. If there's a one next to like a 2, 3, that's problematic because that will always be less than five. So that's why we can eliminate one from these. Hmm. So this can't be 9, 1, or 4. It could be 2, 3, 5. It can't be 3. 2, 5, 6, 7, or 8 is possibility here. Hmm. What else do we have? This 5, 6, 8, 9 pair must add up to 14 because they both can't appear here. That means the other one has to be here. So it must match these two. So these yellows essentially match these. Oh, so this 5 or 6 cannot be that one because this must be a different set. So we're going to mark those a different set. This must be the yellow. This is the orange 8, 9. The orange 5, 6. Ah, okay. Where is the orange 5, 6 in box 5? Can't be either of these two. And this yellow, again, this yellow does not appear here. That means it must appear somewhere here. And it has to, this 8 and 9 also does not appear here, but the other 8, 9 has to be here. And since this 8, 9 adds up to 14 with this 5, 6, there has to be another 5, 6 here. So this is 5, 6, and this is 5, 6. So this cannot be 5 and 6 here. Actually, that forces this to be a 3, 7 pair. Interesting. Therefore, this can't be 7. This can't be 7 because, yeah, this is a 3, 7 pair because there's no other place for the 3 and the 7 to be in box 8. So this has to be a 3, 7 pair. That means 5, 6 is here. This orange 5, 6 sees these. This yellow 5, 6 sees these, so this can't be 5 and 6. Therefore, it's a 3, 4 pair here. That eliminates 3 and 4 in the rest of the column. This can't be 3. This is 7, which makes this 3. This can't be 4, 7. This is the yellow 5 and 6 then. So this can't be 5 or 6. We now have a 2, 4 pair in the box 2, which eliminates 2 and 4 in the rest of the box. So this is 7. That 7 means this can't be 7. This is 6 and 9, adding up to 15. This has to be a 7, 8 pair. So this 6 eliminates 6 here. So this is 5, which makes this 9. This must be 6 and 8, so that's 6 and 8, and this is 9. So this becomes a 6, 8 pair. This cannot be 6 or 8, therefore this is 9 here. This can't be 6 or 8, it's a 4, 5 pair. This 9 eliminates 9 from being here, so this is 6 and 8 here. This can't be 6 or 8. This can't be 6. We have a 1, 2, 3, 4, 5 quintuplet. Quintuplet in column 1, which eliminates 1 through 5 in the rest of the column. Therefore, this is 7 or 8, but it can't be 8 because of the 8 in the box. So this is 7, this is 8, this is 7. That 7 eliminates 7 here, so this is 9 and 7. We have a 1, 2, 3, 4 quadruplet in row 1, which eliminates 1 through 4 in the rest of row 1. This can't be 2 or 4, this is 5. This can't be 2, 4, 5, or 7, so this is 6. That eliminates 6 from the rest of the box and the column. So where is 6 in box 6? It can only be here, so with the 8, it has to be a 6-8 pair. Where is the 5 in column 1? Well, actually, never mind. It could be any of those, so that's not. This can't be 5, though. And these can't be 5, so this is a 2-4 pair. Where is the 7 in row 3? It can only be here. So this is 7. 5 has to be one of these two, which doesn't tell us very much. Okay. We know 9 can only be one of these two. And if 9 were here, that would add up to 15. So this would not work because this would not be the high maximum domino value in box 7. So 9 has to be here, which makes this 8, which makes that 9. 8 eliminates 8 here, so this is 6 and 8. 6 can no longer be here. The rest of... So this can't be 6. Where is the 6 in box 4? It has to be here. So this is 6. The remaining digits in box 7 are 1 through 5, but obviously this can't be 5. This can't be 1, because if this were 1, the problem is it would be next to a 2, 3 guaranteed, and that would be a smaller domino. So the 1 has to be either here or here, so this can't be 4 anymore, because if this were 4, the 1 wouldn't have a place to go in box 7, right? Because this would be a 2, 3 pair, and 1 could not be either of these. Now we have a 1, 2, 3 triplet in column 3, which eliminates 1, 2, and 3 in the rest of the column. So this can't be 2, this is 4, this is 2. That eliminates 2 from being here, which means this can't be 3, this can't be 2, this can't be 2, and so that can't be 3 there. We have a 1, 3, 4 quadruple or triplet in column 2, which eliminates 1, 3, and 4 in the rest of the column. Therefore, this is 5. That makes this 2, which makes this 5. This has to be a 1, 4 pair, which eliminates 1 and 4 in the rest of the box and the row. So this has to be 5. This is 4. This can't be 1 or 2. This is 3. That eliminates 3 here. This is 1, 3. This 1 eliminates 1. 1 and 3 eliminate 1 and 3 here. So this is 2, which means this cannot be 2, 3. This is a 1, 4 pair. This cannot be 2 and 3. It's a 1, 4 pair. The 1, 4 pair here eliminates 4 here, so this is 3. This can't be 3, 4, or 6, so this is 5. 3 eliminates 3 here, so that's 4. This can't be 4. This can't be 2 or 4. This can't be 4. This can't be 2 or 4 because of the 1, 4 pair here. This 3, 5 pair eliminates 3 and 5 in the rest of the column. This can't be 3 or 5, and it can't be 1 because of the 1, 4 pair here, so this is 2. The 3, 5 pair eliminates 3 here, so that's 1. This cannot be 1 and 4, it's 2 and 3. This 2, 3 pair eliminates 2 here, so this is 4. This 2, 3 pair eliminates 3 here, so it's 1. This is 3, this is 2, which eliminates 2 here. This 1 eliminates 1 here, so it's 4. This is 1. This 1 eliminates 1 here, so this is 4 and 1. This can no longer be 2 or 3 because that would be less than the 5. And it cannot be 5. So this is 6 or 7 here. These obviously can't be 5. This 1, 4 pair eliminates 1 here. So this is not 1. This is 2, which makes this 1. This can't be 7 because of the 7 in the row, so this is 6. This can't be 6, 7, or 3, so this is 2. That 2 eliminates 2 here, so it's 3 and 2. 6 eliminates 6 here, so it's 8 and 6. 8 eliminates 8 here, so it's 9 and 8, which makes this 7 and 9. This 5 eliminates that 5, so it's 4 and 5. This can't be 2 or 3, so it's 7, which makes this 3. Okay, what else do we have? Hmm. Okay. We just know this can't be 1 and 3 specifically, but does that tell us anything? I don't know. Um, yeah, none of these digits is gonna be less than 5 with these. Hmm. Ah, if this were 2 and 3, that would add up to 5, and therefore would have to be marked with the cage. So this is 5, therefore that's 3. This 5 eliminates 5 here, so that's 3 and 5. This cannot be 1, because that would be 1 and 3 here, which would be 4, which is less than 5. So this is 4, this is 1, this is 1, this is 4. And that's how you solve it. Yeah, pretty interesting use of the minimum maximum dominoes, particularly to disambiguate. Like, it was used very useful for solving earlier, or for the break-in. And it was also useful as the last few steps to basically figure out what could and could not be, particularly in this deadly, this ambiguous coupling here, this 3-5, right? So, yeah, pretty nice puzzle. I liked how you use the maximum and minimum dominoes throughout for the break-in and all the way to the end of the puzzle to disambiguate the pairs that were possible. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.